Welcome to my Geography Inquiry project. My inquiry question is, why do areas with similar minerals often have similar landform features, and how does this affect human settlement patterns? Get ready, because the why of where is where it's at. We're going to start by breaking the question down into two parts. The two main parts of this question are, number one, why do areas with similar minerals often have similar landform features? We're going to answer this question first, and then we'll get into the human aspect of it, which is, number two, how does this affect human settlement patterns? We're going to start with the first part. So, why do areas with similar minerals often have similar landform features? Well, first, we have to make sure that this is actually true. We can do this in many ways, but we're only going to look at one example today. I would like to present to you Exhibit A. This is a map of Canada's landform regions. These landform regions are distinguished from one another by surmountable differences in the types of landforms found there. Also, the landforms within each region are similar. This is a mineral map of Canada. It shows the kinds of minerals found in the soil around Canada. As you can see, the mineral map and the landform map are very similar. This is evidence that yes, areas with similar minerals do often have similar landforms. As we go, we will see more proof of this, so for now, one example will do. Now we know that yes, areas with similar minerals do often have similar landform features. Let's look at why. The answer to this question is rooted in how landforms are made. There are 4 different ways that landforms form. Some landforms are formed through a combination of these things. They are structural/tectonic action, erosion, weathering, and deposition. So, how are landforms formed through tectonic action? And how might this affect the minerals in those areas? The main types of structural landforms are fold mountains, rift valleys, and volcanoes. These landforms are all formed through the motion of tectonic plates. You may remember plate tectonics from first term, but let's review it anyway. Okay, so basically the Earth's crust isn't all one piece. Rather, it is divided into many separate pieces or plates. These plates are floating on a layer of magma called the mantle, and they are constantly shifting and bumping into each other due to convection currents beneath. When two tectonic plates are pushed together by these forces, we call it converging, a fancy word for coming together. So, what happens when these plates come together? Magic. Well, not exactly. One of two things usually happens. Either the heavier plate is forced under the lighter one, creating a trench, or the two plates converge and force each other upwards, thus creating mountains. Of course, this happens over millions of years, not 10 seconds. Now, let's look at the effects of this on the minerals in an area. All over the world, the base of the continental crust is made of granite, gneiss, schist, sedimentary, and volcanic rocks. During tectonic upheaval, we can expect to see that bits of these rocks from the base of the continental crust rose up and entered the more immediate soil. If we can find evidence of these older rocks in the soil or in deposits in Old Fold Mountain, then this provides evidence for our theory. A very good example of such a mountain range happens to be right here in North America, the Rockies. According to the BC government, the Rockies are a wealth of metasedimentary rocks, mainly schist, gneiss, granite, and many other miscellaneous sedimentary and metamorphic rocks. This supports our theory. Way to shake things up! Now we know why landforms formed through tectonic action often have similar minerals. Next, we will learn why weathering and erosion affect minerals found in certain places, and how they can affect the landforms in that place. Weathering and erosion are related forces that act upon landforms, changing how they look. Weathering is a force that dissolves rocks, and erosion is a force that breaks rocks off landforms and moves them to other locations. The way in which erosion and weathering relates to minerals in landforms is that older landforms have been exposed to more weathering and erosion than newer ones. This makes similarly aged mountains, cliffs, etc. look similar and have similar features. Also, similarly aged places tend to have similar minerals. This is because the Earth, which has been in existence for 4.6 billion years, has experienced many different geologic ages. These ages have varying degrees of heat and pressure. For example, the Precambrian era, which is when the Canadian Shield was formed, was an era of incredible heat on the Earth. This means that a lot of metamorphic and igneous rocks were formed during this time. The Canadian Shield does have a lot of granite, diorite, and basalt, which are all igneous, and schist and marble, which are metamorphic. This is only one of many examples of how the eras of which landforms are formed affect the minerals in them. To recap, weathering and erosion make similarly aged landforms, which tend to have similar minerals, look similar. Now, for the final part of this equation, deposition. Deposition is when land features are formed through the deposit of eroded and weathered materials into a new area. If pressure is applied, these sediments can become sedimentary rock. Deposition can cause landforms such as beaches, floodplains, and deltas to form. In fact, the Canadian prairies were created by deposition. Millions of years ago, glacial movement flattened the area that is now the prairies. As the glaciers melted, they deposited minerals and sediments in their wake, which left behind fertile soils, ideal for farming. Many flat areas were created in this way. They are known as outwashed plains. These glacial deposits shape many plains around the world, which explain why these areas often have similar minerals. The other reason why two plains might have similar minerals is because they both were once at the bottom of a body of water. This explains why many plains might have a lot of sedimentary rock, because sediment that sank to the bottom of this body of water could have been compacted over time by the intense water pressure above it. This is how Australia's Western Plains were formed. You've heard a lot today, so good job if you're still listening. Now, it's time for a review. Landforms can be formed in 4 ways: tectonic action, erosion, weathering, and deposition. Landforms formed through tectonic action have similar minerals because minerals from the base of the continental crust are brought to the surface during tectonic upheaval. Landforms that have experienced weathering and erosion not only look the same, but are often around the same age, which could cause them to have similar minerals. Finally, deposition can cause outwash plains to have similar minerals as a result of glaciation, but can also cause areas that were once underwater to have similar landform features and minerals. Phew, that was a lot, but there's still more answering to do. Looking at the themes of geography, or prime, we can see that we have talked a lot about region. We have drawn connections between how regions are shaped and formed, and how this affects the minerals found there today. We have also talked about the physical aspect of place, but you may be asking, why does this matter to people? In addressing the question of how this affects settlement patterns, we will be talking about the human aspect of place and the interaction part of prime. Settlement patterns depend largely on the landforms and minerals around them. Today, we will be looking at 2 different regions. Firstly, we will be looking at plains and deltas, and secondly, mountains. Plains and deltas are mostly flat areas that experience little or no changes in altitude. If they occur in a moderate climate, with a good amount of rainfall, then they are often very fertile, and thus used for agriculture. So how does this affect human settlement patterns? Well, plains are often rural areas, and therefore have rural settlement patterns. These areas probably have dispersed settlement, as most people living there have extensive lots on which to grow things. Here's where the why-where comes into play. Here, we will continue to talk about why people live where and how they do. Mountains are another landform that has had great influences on the human population. Because the land that makes up mountains was once a part of the continental crust, it has many valuable mineral deposits. This encourages the growth and development of mining towns. However, the geography of the mountains discourages the development of large towns. This is further discouraged by the fact that most of these valuable minerals occur in small pockets rather than large areas. This promotes the growth of many small towns. We can check if this hypothesis is supported by actual data. If this is right, we can expect to see that the mountainous regions often have plentiful but smaller settlements. Here's a map of the settlements in the Andes. Here, we can see that relative to the areas next to it, there are many small towns. The small towns on this map are the smaller white dots, while the bigger towns are bigger dots with black circles in the middle. As we can see, this evidence corroborates our theory. Though mountains and plains are far from the only kinds of landforms, They are the main ones that affect human settlement patterns, both by the minerals that are found there and by the nature of the landforms themselves. Many other landform characteristics, such as bogs or wetlands, may affect human settlement patterns, in that they are difficult to build on, but the minerals that exist there don't really matter to us. Also, many landforms regions can be described through a combination of mountains and plains. The rolling hills of England, for example, about 90% plains and 10% mountains. Thanks for watching, and I hope you enjoyed my project. In case you were worrying, all paper used in this video will be reused as newspaper. I just may get a few weird looks from my teachers.